right, a continuation from yesterday. So the first one says we have 6 square root of 12 minus 2 square root of 3. We do not have like radicals, which means I would want to see if I could simplify them to then be able to have like radicals and combine them. So square root of 3 cannot simplify because the only things that multiply to give me 3 is 1 times 3. So we're going to check out square root of 12. Well, we have 1 times 12, 2 times 6, and 3 times 4. So our largest perfect square would be 4, okay? So we're going to use 3 times 4, and we're going to rewrite square root of 12 to be the square root of 3 times the square root of 4. So we get 6 square root of 3 times square root of 4. I didn't change square root of 12, right? I just rewrote it as square root of 3 times square root of 4. So then we know square root of 4 simplifies to be 2. So we get 6 times 2 times our square root of 3. I didn't change the square root of 4, I just rewrote it as what it simplified to be, which is 2. So 6 times 2 gives us 12 times the square root of 3 minus, and we're bringing this down, 2 square root of 3. Now we have like radicals, so now we can combine them. 12 square root of 3 minus 2 square root of 3, well 12 minus 2 gives us 10 square root of 3 as our final answer. Okay, let's look at example 2. Okay, notice we have 2 times square root of 3 minus 4 square root of 27. Okay, so what we would want to do is go ahead and simplify inside of my parentheses if I can, and then we distribute that 2 to everything. Okay, so let's look and see if square root of 27 could simplify to be a like radical with square root of 3. So square root of 27, we have 1 times 27. It's not divisible by 2. It is divisible by 3. And that is it. Okay, you could try 4. It wouldn't work. 5, 6, 7, 8. None of them work. These are only things. And our greatest perfect square would be 9. So we're going to use 3 times 9. So I'm going to have 2 times the square root of 3 minus 4 times the square root of 3 times the square root of 9. Well, we know square root of 9 simplifies to be 3, which leaves us 4 times 3. Okay, I just replace square root of 9 with what it's equal to, which is 3. And then I'm bringing down this square root of 3. So these are like radicals. We know negative 4 times 3 would be a negative 12. So 2 times the square root of 3 minus 12 square root of 3. Okay, so we get 1 minus 12 gives us negative 11. So we get 2 times negative 11 square root of 3. Ignore this, right? 2 times negative 11 square root of 3. Well, 2 times 11, you don't multiply it. A number on the outside of your radical cannot multiply with the number inside the radical. So we get 2 times negative 11, which would give us negative 22 square root of 3. Okay, and last but not least, okay, is this example here. Draw a line to separate the problem above. So 3 square root of 24 minus 2 square root of 12 minus square root of 3. Okay, we have 3 different radicals right here. Square root of 3 we know cannot simplify, but we need to simplify both of these others to see if any of them are like terms, okay? Or like radicals, sorry. So we'll start with square root of 24. The things that would multiply to give me square root of 24 would be 1 times 24, 2 times 12, 3 times 8, 4 times 6. 5 doesn't work, so we are done, okay? And then I'm going to start at my largest number and figure out my greatest perfect square. So we don't have a perfect square until we get to 4. So 4 is our greatest perfect square. So we're going to rewrite this as 3 square root of 4 times square root of 6. And then I'll go ahead and bring down my minus 2, and now I've got to simplify square root of 12. Okay, let's bring it over. So we have 1 times 12, 2 times 6, and 3 times 4. So my greatest perfect square for this one is also 4. So we're going to rewrite square root of 12 as the square root of 3 times the square root of 4. And then we're bringing down minus square root of 3. Okay, So I haven't changed anything. All I did was simplify or replace square root of 24 to be square root of 4 times square root of 6, because 4 times 6 is 24. And we wrote square root of 12 to be square root of 3 times square root of 4, because 3 times 4 is 12. Now we want to simplify our perfect squares. So square root of 4 is 2, which means I have 3 times 2, square root of 6. And then we have minus 2 times square root of 4 is 2, times 2, square root of 3. And then we bring down our minus square root of 3. 3 times 2 gives me 6 square root of 6. Negative 2 times 2 is a negative 4 square root of 3, minus square root of 3. So we do have like radicals right here. A negative 4 square root of 3 minus 1 square root of 3 gives me a negative 5 square root of 3. And this would be our final answer because these two are not like radicals and they are simplified, which means we are done. Last example, what is the perimeter of the rectangle below? Okay, so if you recall, perimeter means you add all sides. Okay, not just the two sides that are given, since we know it's a rectangle, opposite sides are the same. So you know this side is also square root of 50 and this side is also square root of 80, right? So let's first start with square root of 50 and let's simplify that. Okay, so we would get 1 times 50, 2 times 25. If you divided it by 3, it wouldn't work. 4, it wouldn't work. But you would get 5 times 10. And that ends up being the only things that 50 is divisible by, or the only things that would multiply to give you 50, okay? Our greatest perfect square would be 25, so we're gonna rewrite square root of 50 to be, we'll leave it off to the side, square root of 2 times square root of 25. And we know the square root of 25 is 5. So that means it equals 5, square root of 25 is 5, times the square root of 2. So that's what I'm going to rewrite this side to be. And its side across from it, which is the same. Okay? Now we're going to look at square root of 80. Okay? So we get 1 times 80, 2 times 40, 4 times 20, 5 times 16. And 8 times 10. Those end up being the only things that multiply to equal 80. So our largest perfect square here is 16. So we're going to rewrite it to be 5 square root of 16. Our square root of 5 times square root of 16. And we know square root of 16 simplifies to be 4. So this gives us 4, and then we bring down our square root of 5. So we're going to rewrite this to be 4 square root of 5. Notice these are not like radicals. If they were, I could combine all 4 sides together. Since they're not, we'll just combine our opposites. 4 square root of 5 plus 4 square root of 5 gives me 8 square roots of 5. And then we also have 5 square root of 2 plus 5 square root of 2, which gives me plus 10 square root of 2. This would be my final answer. Okay, you can't combine these, so it just stays as these two added together and these two added together. And that's it.